Okay, so if we are going to solve rational inequalities, these are the steps I gave you yesterday, but we're going to actually have to do the first two steps because the ones I gave you yesterday, everything was already on one side and combined into one fraction. So whenever we do these problems, we want to start by moving everything to one side. So what you're going to do here is you'll have 6 over x plus 3 minus 2 over x is greater than 0. And then a mistake that a lot of students make is they go from right here. They start finding, well, like x would equal 0. Maybe not on this one because there's no x's in the numerator. But before you can do what we were doing yesterday, everything has to be combined into one fraction. And to do that, you've got to get common denominators. This one, we almost have common denominators, right? The only thing we really need is this right now has a denominator of 1, so we need to add an x in the denominator and an x in the top. So we will have 6 plus 3x minus 2 on the top. And then the denominators, all of them are just x, so you're going to write x one time, right? Because when we add or subtract fractions, we add and subtract the numerator, the denominator just stays the same. And then we want to combine here, so we would end up with 3x plus 4 over x is greater than 0. So we did not do any of that yesterday because I didn't give you any problems that required it. But it's similar to what we've been doing for solving equations. The only thing is for equations, you don't need to move everything to one side. You could if you wanted to, but there's no need to move everything to one side. With inequalities, you want to make sure that you do that. You want to move everything to one side because you need it to be greater than or less than 0 for that. So here, we're basically where we were yesterday. And we are going for our 3x plus 4 over x greater than 0. We're going to factor the numerator and denominator and find the zeros that go with each binomial. For this particular problem, the numerator and denominator do not factor. So we would just have these two. We'd have 3x plus 4 would equal 0, which will give us 3x equals negative 4. And if we divide by 3, we get x equals negative 4 over 3. And then in the denominator, we just have x equals 0. And so for this problem, we would put negative 4/3 and 0 on our number line. Make the chart if you want. This is a pretty small one, but I still just prefer the chart. You guys seemed to do pretty well with the chart yesterday, too. There's usually a kid or two that doesn't like it and just plugs numbers in, but I prefer it. So 3x plus 4, it's going to be negative if you plug anything below negative 4/3. It will be positive for numbers bigger than that. X is negative when you plug in a negative number, positive when you plug in a positive number. So for your answer, down here, you'll get positive, negative, positive. We are right here. Okay. And then we're just looking for the answers that make our inequality true, which for this problem, always make sure you look at the problem once you have moved everything to one side and got common denominators. Because if you go back to the very original equation, you've got this 2x over 2 over x right here. You can't tell if things are positive or negative there. So you want to make sure you're looking at what you've got once everything's combined, and that is greater than 0, which is positive. So we're looking at these two sections right here. And since you don't have an or equal to sign, everything's going to be parentheses. You don't even have to think about it. We got negative infinity to negative 4/3 and 0 to infinity. Okay, questions? So the end of all these problems should be like what we were doing yesterday, but the beginning is going to be a little bit more complicated. So here's another one. This problem, you do already have common denominators. If that was an equal sign, we could just mark the denominators out, but it is not. So we cannot do that. It'll cause you to miss parts of your answers if you do it. So for this problem, we want to move everything to one side, which will look like this: 2n plus 1 over 3n plus 1 minus n minus 1 over 3n plus 1, and that'll be less than 0. And for this particular problem, you already have common denominators. So we just need to put those together. What you've got to be really careful of that will cause you to miss this problem is you're subtracting this whole thing right here. So this negative has to get distributed to both of those terms. So you'll have 2n plus 1 minus n plus 1. And then the denominators are the same, so you're just going to write that once. And then you can combine in your numerator, so you'll get n plus 2 over 3n plus 1. Alright, so we will get n equals negative 2, and here you'll get n equals negative 1/3. We're just setting that equal to 0, subtracting that 1. 3n equals negative 1, divide by 3 to get that. So we will put those numbers on a number line. We will have n plus 2, 3n plus 1, and our answer. And so you'll get negative, positive, positive here, negative, negative, positive here. And it's going to look similar to our last one: positive, negative, positive. Okay, so which ones are our answers for this one? Positives or negatives? Negatives, because we've got less than 0, so negative, which means just this section right here. You don't have an or equal to sign, so it is parentheses negative 2 to negative 1/3. Okay. Questions? All right, here's another one. All right, like the last problem, I'm going to move everything to one side. 3 over x minus 3 is, or minus 2 over x plus 2 is less than or equal to 0. We do not have common denominators this time. So just like we were doing with our equations, we need to think of a common denominator here. In this case, it's going to be x minus 3, x plus 2. So this first fraction needs to be multiplied by x plus 2 in the numerator and denominator. The second one needs an x minus 3 here. And so be really careful right here with this negative, that makes that 2 negative. So when you distribute this, make sure that negative goes with the 2. That minus sign, it's really easy to miss that. So you'll get 3x plus 6 whenever you distribute your 3 here. And then you'll get minus 2x plus 6 there. And then in the bottom, the denominator just stays the same. Don't multiply it back together. Because if you do multiply it back together, you're just going to need to factor it back, because you have to factor it whenever you're making your chart. So just leave it like it is. Don't multiply those back together. So, and this is less than or equal to 0. So we're going to end up with x plus 12 over x plus 2 times x minus 3. Less than or equal to 0. And then this is just like from yesterday. I'm going to run through it pretty quick. You're going to get x equals negative 12, x equals negative 2, x equals 3. We're going to put those on the number line. We're going to put our factors over here, x plus 12, x plus 2, x minus 3, and then room for our answer. And then we're just going to fill this in real quick. So our answer is going to be negative, positive, negative, positive. Okay. This one we do have to think about a little bit more, because we've got the or equal to sign right here. So we are looking for negatives, but we got to think about excluded values. So our excluded values, what are they? Negative 2 and 3. So negative 2 and 3 are excluded values. So I want to use brackets, but I cannot for negative 2 and 3 because those are excluded values. So when we write our answer for this, we will have negative infinity to negative 12. We are going to use a bracket with the negative 12. And then over here for the negative 2 and 3, we would like to use brackets, but they are excluded, so we cannot. So it will be negative 2 to 3. It comes from the numerator, so no, it's only the ones from the denominator. Okay, here. All right, let me see. I don't think there's anything too special about number 3 that's going to make us need to do it, and I think you guys are probably in pretty decent shape on these, so I'm going to skip 3. The only thing a little bit different about 3, but we already saw this in the warm-up, when you have a factor that's 4 minus x, instead of going negative, 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 positive, 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 whenever you switch, it switches where you got positive, positive, and then switches to negative on those. So that's the only thing that you're going to kind of run into on number 3. So that you have a little more time to work on your actual assignment, let's just skip on over to 4. 4 is a little bit of a bigger problem. We want to move everything to one side. And what I'm going to do is I'm going to kind of factor as I move it, because you do want to factor. I'm going to put this 3 over 1, so I don't forget about its denominator. And then I'm going to have 4x plus 1 over, and then I'll have x minus 5, x minus 1 greater than. Let's put it or equal to on this just to practice the little bit more difficult scenario of having that or equal to. So we have our 2 over x minus 5 plus 3 over 1 here. We're going to have a common denominator of x minus 5 times x plus 1. And let's see. Here is your worksheet. I'm good, thank you. Alright, so to get common denominators for this one, we need an x minus 1. For this one, we need both the x minus 5 and the x minus 1. And then the last one does not need anything. Technically, you could multiply that 0 if you want to, but 0 times anything is just 0, so you don't really need to do that. So we here can distribute this. We will get 2x squared minus 2x. For the next part, I would do this in 2 steps because you need to multiply this stuff together and then distribute. Or you could distribute the 3 and then multiply that together, but the 3 doesn't go to both things. So I usually just do it this way. So I'm going to have 3 times x squared. I guess it's going to be a minus 5 minus 1 will give us minus 6x plus 5, which is this denominator over here. We could have done that, I guess. Be really careful here. It is minus 4x plus 1. This negative has to get distributed to both of those. It will cause so many of you to miss a problem because it's so easy to overlook that. And then the denominator for all of these is x minus 1, x minus 5, even though I did fail to write that here. And then just to continue simplifying that numerator, we'll have 2x squared minus 2x plus 3x squared minus 18x plus 15 minus 4x minus 1 all over x minus 1, x minus 5 greater than or equal to 0. And we are going to combine our like terms. So we got 5x squared minus 24x plus 14 all over, I think, x minus 1, x minus 5. And then we want to factor that numerator, if it will. I hope it will. If not, this is going to throw a... Seems like I'm vaguely remembering having to not being able to factor on these. You got 7 and 2. Minus 2 minus 7 does not work. 14 and 1 does not work. Ugh, okay. Alright, this is like a bonus type problem. Right here that I might give you something like this, but it will probably not show up on the regular part of the test. All right, so bottom is fine. It's already factored. We know x equals 1 and x equals 5 are two of our points that need to go on there. I need to know what would make the numerator 0 also. So 5x squared minus 24x plus 14 equals 0. But unless I'm missing something, I don't think that factors. And I don't think I made a mistake earlier unless somebody has seen something, because sometimes that's my problem. So that will not factor. So how do I solve that? Quadratic formula. So I'm going to have x equals positive 24 plus or minus square root of negative 24 squared minus 4 times 5 times 14 all over 2 times 5. And if I end up with an I in this one, we're quitting. Let's see, 24 squared plus 4 times 5 times 14. No, we get a positive number. Okay. So we get x equals 24 plus or minus square root of 296 over 10 and let's say if I give you this, because if I simplify that with radicals, it's going to be really hard to tell where those numbers fit in between 1 and 5, right? So let's say if I give you this, let's use decimal approximations for it. So what I'm going to do in my calculator is I'm just going to type in 24 plus the square root of 296 and divide that by 10. And that will give me 4.120. If I round, I'm just going to round that to 3 places. It's slightly off because I'm rounding, but it'll be good enough. And then I'll do 24 minus the square root of 296 and divide that by 10, and that gives me 0.680. So the decimals are going to be really necessary, because if you try to figure out if 24 plus or minus the square root of 296 over 10 is above or below 5 and 1, it's going to be really difficult. So if you see something like this, it's probably a bonus problem, then I will give you a calculator on it. I think this test, I usually let you use the calculator on the whole thing, but I won't for most everything exact answer. Something like this would be an exception to that. So our line is going to have 0.680. We'll have 1. We'll have 4.120 and 5 on our line here. And then our factors over here are going to have to be 5x squared minus 24x plus 14. That one factor. And then x minus 1, x minus 5, and then the answer. I'm going to go ahead and do my lines for my x minus 1 and x minus 5 first. They're much easier. The x minus 1 will be negative, negative, and then the rest positives. The x minus 5 will be negative all the way up to that 5, and then it will be positive. And so, again, if I give you this, I will give it to you with a calculator. So, like, if we pick a number below 0.680, I would pick 0. If you plug in 0 to this, you'll get 14. So that will be positive. Then, if we pick a number between 0.68 and 1, so maybe like 0.8, I'm going to type that in. And I get negative 2, so that one's negative. I bet it's going to be negative for the next one because usually what you see with a quadratic is it dips below the x-axis and comes back up. So this next one I think is also going to be negative. But if I plug in like 5 times 2 squared minus 24 times 2 plus 14, also negative. And then I'm pretty sure for numbers bigger than 4, you're going to get positives, but we'll get 5 times, like if we do 4.3 squared minus 24 times 4.3 plus 14. We'll get a positive. This one's going to be positive too. So if you end up having to use one that's a quadratic, it is going to switch twice. We haven't seen that before. We've either seen something that, like just like an x squared that is always positive, or we've seen things like x minus 1, x plus 5, things like that. So if you see a quadratic that is a full quadratic, like an x squared plus 7x minus 3, it is probably going to switch twice over that span. So, keep those. All right, I don't know what I did, but hopefully it didn't go away. So if we do our answer now, here we'll have positive, negative, positive, negative, positive. Which ones are our answers? Positives. So we've got this section, and this section. We want to use or equal to, but we do have some excluded values. What are they? 5 and 1. So 1 is out, 5 is out. So to write my answer for this, I would do negative infinity to 0.680. I'll do parentheses 1 to 4.120, and then 5 to infinity there. Okay. As far as having to use quadratic formula, I don't think you're probably not going to see it on the worksheet because the worksheet does a better job. But this also lets you know, like, if you continue, let's say you mess something up and you get something that won't factor, you can do this and get a lot of partial credit, even if the answer was supposed to factor and give you a whole number. Because it'll be clear to me that you understand what you're doing, you just accidentally forgot to distribute a negative or something that, so that'll be like very minimal points off if you can finish that problem out there. Yeah. Yeah, and I'll grade all these by hand, so that will, you can get partial credit on those. Because if not, if I don't grade these by hand, then I usually have really terrible grades. Because it's really easy to make a mistake somewhere. Okay, so this worksheet has a little bit of both types of problems on them. Some of these are like you guys were doing yesterday, where it's already less than or equal to 0 or greater than 0 or whatever. Some of the others are going to require you to move the values. Let me make sure, like, if you guys look at, what's number 3? Tell me what number 3 is. I think it's 3. X plus what? Okay. So even though this just has a 3, it's got to come over to the other side. X plus 3 over X plus 6 minus 3, which is like 3 over 1, less than or equal to 0. Then you've got to get common denominator. So even if it's just a whole number there, it's got to go over to the other side. The only way you can just fly in on it and do it like we were doing yesterday is if it's less than 0 or greater than 0. So some of those problems are like that, but not all of them. Okay, questions? All right, we've got about 30 minutes for you to work on that, so hopefully you can get a lot of it